Okay, I wanted to do some videos over some simpler problems. Your book goes from one simple problem to really hard problems, and it was proving to be a big challenge today for a lot of students. So we're going to go with some simpler problems. And the ones on the test will be like this. They're not going to be those harder ones, okay? You need some practice on easier ones before you can do the hard ones, and so this is what we've decided to do. Okay, so we're going to use this problem. What we're going to do is we're going to complete the square, and what we're going to do is do a series of things. We're going to use it to find the vertex. We're going to state our y-intercept, and let's see, we're going to find a reflection point. Okay, and we're also going to find our x-intercepts. And one thing that we learned in class, that x-intercepts are the same things as our solutions. So if I solve the problem, those solutions are going to be my x-intercepts. They have other names too. Sometimes books call them zeros, and sometimes they call them roots. Okay. So we're going to solve this. We're going to use completing the square, and we're going to do all this pretty much off this one equation by completing the square. I want you to notice something about this equation first. This is one of the reasons I need to complete the square. If I complete the square, I can find my solutions and my vertex and all that stuff pretty easily. This problem doesn't factor, so I can't solve it by factoring. I could use a quadratic formula, but this is, again, a lesson on completing the square, so we are going to use that method. When I complete the square, what I do is I set remember, g of x is the same thing as y. It's just another way of writing it where they could tell me, if they wanted me to plug in 2, for instance, they could say g of 2 really easily. So we kind of are getting away from seeing y equal stuff in our book to more where we're going to see, like f of x, g of x, h of x. But when we complete the square, what we do is we set that equal to 0 temporarily. And then what I'm going to do, if you remember, is we move our constant over to the other side. We would have negative 1 is equal to x squared plus 4x. Now when we complete the square, here's what we do. We take the b term, and remember, I'm looking at this as this is ax squared plus bx. I could have labeled it up here, ax squared plus bx, but a lot of times we don't remember to do it, when we get started. And what I'm going to do is take this b, which is 4, and I divide it by 2, and I square it and add it to both sides. Remember, that's the big deal with completing the squares. We're going to add b over 2 squared to both sides. And that causes us to create a perfect square. And the reason I do this is I want to put this in a different form, have a different form of an equation that's commonly used in your upper level math. And so what we would do, if that's 4 divided by 2, that's 2 squared. I need to add 2 squared, which is 4 to both sides. Negative 1 plus 4 is 3. And the reason I did that is, if you remember, when I add that b over 2 squared, it creates a perfect square. The perfect square it creates is x, and then what I do is I look inside of here. 4 over 2 is 2, a positive 2. This would be x plus 2 squared. If you want to check that out, if you went over to the side and you multiplied out x plus 2 plus x plus 2, you would get x squared plus 4x plus 4, which is what I have here. This just puts it in a nice form to be a perfect square. Now there's advantages to that, and I'm going to expand on this in a minute. But right now, if I just want to write the equation, remember what I do after I add that to both sides and simplify is then I'm going to move that 3 back over to this side, and I get 0 is equal to x plus 2 squared minus 3. And remember how I temporarily set y equal to 0 up front? Well, now I'm going to change it back out. It just kind of made it a little easier to mess with everything. Some books don't have you do that, but it's an easier way to kind of clear it out for just a minute. Now I can tell right now my vertex is, remember, this is the form. Let me go to the next page. Let me just copy this. Okay, I can't see what I wrote, but I believe that I messed that up, and that needs to be a minus 3. I really can't remember, so I'm going to assume it's a minus 3 there. I can't go back once I start recording and see things that I wrote before. All right, if you remember, this is in the form of that handout that I gave you, that foldable. I'm sorry, I already messed that up. It's a times x minus h squared plus k. And in that form, my vertex is my h and my k. That's why people like this form really well and why it's so commonly used as we move up. We kind of get away a lot of times from using equations that are written in the form that we were given it in this problem. Now, if you remember, the thing you got to be careful about is this formula was x minus h. I have x plus 2, so I'm going to need to rewrite that as x. Isn't positive 2 the same thing as minus a minus 2? If I do that, here's my x, my subtraction sign. Oh, my h is actually a negative 2 here, right here. Okay, so my h is a negative 2 because the formula had a subtraction sign in it. I need to think about rewriting my plus sign here as minus a minus so that I can actually tell what h is. One quick way to do it is if it looks like it's x plus 2, you would think your vertex would be positive 2, but it's always the opposite of what you think. It's a negative 2 there, okay? And then on the end, I have this minus 3 as my vertex. And again, hopefully I copied that correctly or changed that correctly. So I've got my vertex. So actually, if I want to go graph this, I'm just going to try to sketch a graph to the side because you're going to have to sketch, on the test some too. So I might as well practice it right now on this video. Okay, so negative 2, negative 3. Let me just kind of put some more little marks here for my graph. Negative 2, negative 3 would be negative 2, negative 3 right here. It would be about right here. That's my vertex. Remember, that's my maximum or my minimum, my high or my low point for my equation. Here it's going to be my low point. And the reason I know is I didn't have any negative numbers. If I had a negative number right out here in front of those parentheses, it would make it flip upside down. But this is actually going to be a U-shaped. Now, one of the things we need to know, and again, we've been talking about a lot of stuff in class that's not in the book because it's necessary and this book just doesn't cover it. There's a line that goes from the vertex, and it's called the axis of symmetry. Okay? And the axis of symmetry is a vertical line, so it has an equation, and you need to write it as an equation. It is x equal, well, what was the x coordinate that it goes through? It goes through, negative 2. That's my axis of symmetry. The reason that's such an important line is that it's the middle of my graph, and I can tell a whole lot just by that axis of symmetry. For instance, one of the questions that we were asked is to find one of the things I wrote as the instructions for this so that it teaches us what we need to do, is that we were supposed to find the y-intercept. Well, if you remember, the original equation was y equal x squared plus 4x plus 1. When my equation is in that form that it was given to me, where everything's all simplified and I don't have any parentheses or anything, my y-intercept is always this number on the end here. And so my y-intercept here is 1, just like it is with a line, as long as everything's all simplified. So that's going to be, it's going to cross at 1. So my y-intercept is 1. Now, that's a point that I can graph to get a sketch. But remember, there's something else I told y'all you needed to know, and it's called the reflection point. And what the reflection point is that if I have a point, for instance, that y-intercept, it's 2 away from the axis of symmetry, there'll be another buddy point over here 2 away on the other side. That's how parabolas work. And that's why the axis of symmetry is such a nice thing. So right now, I could tell you that's called a reflection point. And we can figure out what that is, especially if we have a nice piece of graph paper, unlike what I have here right now. That reflection point would be negative 1, negative 2, negative 3. This is negative 4. And the y coordinate is 1. Okay, so I now know a reflection point. If I called that point Q on the test and I ask you, or the quiz, and I ask you for Q prime, that means what's the reflection point of Q? We just put a little line at the top of it to say we want the buddy on the other side. So if it's 2 away on this side, it's 2 away that side, I would be asking you to tell me the point negative 4, 1 that we just graphed. Now there's something else that's missing from this graph. And it's something that our book doesn't talk about, but we need to know how to do because we're going to be using this stuff a lot later in the book. And it's what are our x-intercepts? They're an important part of the graph, and I really should always show those. Well, if I want my x-intercept, what I can do is backtrack. If you look at your notes, back up a little bit. Do you see where we had that 3 was equal to x plus 2 squared? That was back when I was completing the square and trying to find the equation. But back up and you'll see that you have that 3 is equal to x plus 2 squared. Since I've done this much work, There are other ways could try to find the x-intercepts. My choices are to factor, and this one doesn't factor. I could go use the quadratic formula, but we're not going to do that here because, we're trying to learn all the things that we can do by completing the square. If I solve for x, do you remember how at the very beginning, we set the equation equal to 0? That's what you do every time you want to find solutions, is you set your equation equal to 0. So if I set this equal to 0, this is what all came out of it. If I want to know what the x-intercept is, then all I got to do is solve for x. It's caught up here, so what I'm going to do, I got to get x by itself. To get rid of the square, I'm going to square root both sides. So now I have square root of 3 plus or minus square root of 3, because as soon as I square root, I need to write plus or minus on it, is x plus 2, because the square root of something squared is just that something back. Now if I want to solve for x, I could subtract 2 from both sides. And remember, you can't put together things under a radical with things outside of a radical when you're adding and subtracting. My x-intercepts would be negative 2 plus square root of 3 would be one of them, and the other one is negative 2 minus square root of 3, because that's where that plus or minus is coming in. I take the negative 2 and I add it to square root of 3, and negative 2 subtract square root of 3. Those are my x-intercepts. Now if I were to put those on the graph, square root of 3 is about 1.4. So negative 2 plus 1.4 would be like 0.6. So at 0.6 I would have one. I'm going to put these in on as orange just so we can see it. 0.6 looks like it'd be, negative 0.6. I'm sorry, negative 0.6. Let's say it's about right here for some reason. It's showing up kind of reddish, but I meant for it to be orange there. So it's somewhere in there. So this is about 0.6 here. You could put it on your calculator. I'm just trying to do this without getting on the calculator. And negative 2 minus, I'm thinking of this as negative 2 minus about 1.4 would be negative 3.4. So negative 1, negative 2, negative 3.4 would be about right here. Those are my x-intercepts. And so we do need to have those on the graph, and we do need to approximate them, whether you're doing it like I did or you use your calculator. So as I draw this parabola, I'm just going to connect all these points. There it is. It's important that I know how to write the axis of symmetry, that I know how to do the x-intercepts, and that I can identify my y-intercept, my vertex, and then some reflection points. Those are all things you're going to need to do for the test.